All right, in this quiz, we had a number of different problems here. I'm going to scroll through these really quick just to give you a glimpse of what they look like, the solutions. The details relating to all of these solutions are contained in the podcast that follow this one. But I wanted to give you a couple of pointers on the overall quiz itself. The domain questions are surprisingly important in calculus. Not every problem that you'll see down the road will ask you about the domains, but thinking about the domain of a function is an important step in a great number of problems. Later on, it'll be one of the minor steps or one of the first steps that you'll need to do. So you want to be able to quickly recognize a domain and figure out how to find it. The other part that I want to mention on this is that finding zeros is surprisingly important in calculus. You will be finding zeros of many different functions. So the skills necessary to answer this domain question will be repurposed over and over and over again. You will see this time and time again. The problem involving the square root has, again, buried in its core not only a domain question but a quadratic inequality. You're trying to figure out where something is positive or equal to zero. And much like the zeros I mentioned earlier, it's going to be very important to be able to determine when something is positive and when something is negative. And I don't mean for specific values, but entire ranges of values. Which values of x will make this a positive expression, which will make it a negative. And again, it won't just be domain questions where you need to determine this. It'll be a fairly large variety that you'll see coming out throughout the semester. The application problems, again, this is applied calculus, so naturally you would expect those to come up. In the future, we will not only be building these functions, but we will be analyzing them in quite a bit of detail. You may have noticed this is a parabola opening down on this in this problem, so we could have been asked, where is the absolute maximum value? The graph will end up again looking like this, and so the maximum will be at the vertex, and we could have been asked, where is the best value of x to maximize this? And while we're thinking about it, let's just go ahead and answer that question. The vertex is going to be halfway between the two zeros, and the two zeros jump out at me. There's a 0 at x equals 0, and there's a 0 at x equals 400. So the x value that will optimize this would be the x value 200. So if we make this thing 200 feet on this side, and let's see, the other dimension is 1200 minus 3 times 200, so this would be 600. This will end up being 600 feet. So make it 200 by 600, you'll use up your 1200 feet, and you will end up with the absolute maximum area. Questions like that are why we need to study functions in domains. The last problem dealt with visualization. We need to be able to perform some algebra so that we can easily visualize key aspects of a graph. This one had us complete the square in order to see the entire graph, but throughout the semester we will pick up different techniques for being able to analyze a